still some people left here. Thank you very much for being interested in knowing something about what's being done in the chemical industry in Germany. My name is Herbert Hohmann. I'm working for Identech Solutions, and only a few words about Identech Solutions. We are in process automation using active RFID systems in industrial areas, mainly like oil and gas, like intermodal transportation in harbors, and truck applications like in chemical industry. A couple of big customers are using our systems. By the way, it's not only about truck and asset management and process automation, it's also about people safety. So we are doing a lot of business on oil platforms, for instance, in the North Sea and other regions where you monitor people, especially in mustering stations and so on, and we've done that for a lot of years. We are an Austrian headquartered company, and that's obviously why we are being invited by the University of Applied Science in Vorarlberg. Thanks for the invitation. And we are actually spread across the world where we find activities where we are active in. That's the wrong way. Chemical industry in Germany, and actually we are very close to the heart of that main chemical production in Germany. So we are around here, and this picture is from a study association of German logistics, Bundesverband Logistik, and this is the title of that. Fraunhofer Institute also has contributed to that study, and that's where we get a lot of that information from. So in Germany, you look at those centers along the Rhine River with BASF, with the chemical park around the former Höchst company, and then the Bayer complex, which stays called Chem Parks, in 3 cities here, Berlin, Dormagen, and Leverkusen, and then obviously all other centers around Germany. This figure of 158 million tons of chemical products and chemical product transportation is from that study, and this is only within Germany. And the modal mix we are seeing there is mainly trucks, and again, this is only true for the traffic within Germany. Inbound supply or outbound supply has a totally different modal mix. So it's more railways, more ship, and so on. Anyway, there's a lot of truck traffic here, and 40% of that is hazardous material. So there you have to pay special attention, and this is really where also the use case from using RFID there comes from. This information here that's used to kind of scope out the dimension of truck traffic we have here. There are 2,000 plus trucks going in and out BASF plant every day on the chemical parks of Bayer and Lanxess. Here we think that's around 500 to 700 per side. So if you calculate that together, you're probably coming up to 3,000 trucks in that area, 5,000 trucks in this area, and if you think that this is probably like 20% of the total traffic, so you're easily up to 25,000, even more trucks going into and out of plants every day. And what is the challenge actually these businesses facing? There is forecasted an increase in that business, 30 to 50% until 2020. Obviously with that comes increased traffic at gates and within plants. And what they already see today is, especially in that area, the lack of educated drivers, and even the, I mean, we're talking about hazardous material. The increased requirements for safety and security require that you have trucks and equipment which is able to stay these safety and security requirements. Also, there is a limited capacity and space in the gate areas. If you look at plants in Leverkusen or the Bayer plants, they're actually close to the city. So they have limited space to put parking lots or increase the number of lanes and whatsoever. So that's where they have to deal with it. Obviously, we already talked about the requirement for reduction of CO2. I mean, these companies, they have to kind of not only advertise, but kind of prove that they are working towards that direction. So, I mean, everybody needs to be green today, and so there are questions asked, how you do that, and so they actually do something about that. And they have to deal with the complexity of the supply chain, number of involved players that are transporting the goods. What, as a consequence of that, actually the BASF had started to put together a project. This is all around process automation of the gate process. So they started in 2008 with a pilot on one of their gates. So they introduced one lane where the drivers would be processed in an automatic way. They put around 3,000 transponders on selected trucks of selected forwarders. And they had run that system until like 2012, because the proof was if you put an electronic on a truck, and you have to carry that through wind and weather and different temperatures and all the vibration on the truck, will it be able to withstand that environment? And finally, the rollout was decided in 2012. Their new gate being built, or one of the gates has been converted into a truck gate, which was just a passenger car gate before. So now they have fully equipped all the gates with reading equipment to automatically identify the trucks, and have rolled out the tagging of the trucks to their main forwarders. Actually, at the same time, discussions between BASF and Kinyon started. Kinyon is the service provider for the chem parks in Leverkusen, Oerding, Krefeld, and they thought there was a value if they could use the same trucks that go into BASF, also go into those plants. So they decided actually to use the same system and have their trucks equipped in the same way. So now the forwarders can actually use, they don't have to use a different method of identification, they can use the same tag. The only thing today they have to do is actually they have to register once at both of the plants. So that for the future there might be central point of registration for the trucks, but also for the drivers, because as I said, these drivers have to have a special permit being allowed to drive hazardous goods, and so maintaining the database of those drivers, one could envision that this could be a central function that is providing all of that to the different users of the system. What the system consists of first is an ATEX certified, this time active RFID transponder, and there are a few reasons why they chose to use that technology. First of all, it's ATEX, so the ATEX transponder the transponder has to be ATEX certified. Then based on that technology, you are you are getting enough reading distance so you can stay with your electronics out of the ATEX zones. So just the transponder stays in the ATEX zones, but all other devices, electronic devices you have, are staying out of the zone. And still you can read the transponder. That was one of the reasons to go for that technology. So it consists obviously of the readers you need and a software that's collecting the data and filtering data and preprocessing the data. So this comprises the hardware part of the identification system. And then there is a MAS layer on top of that. The name is Flow. And that has functions in check-in, slot booking, handling the wait stations, providing the kiosk software where the driver has to register, and it's providing all the ADR documentation, so on. So this is sorry that this stays in German here, but this is the flow through the system. Actually based on a transport order that usually comes out of SAP. The forwarder gets. The forwarder is registering a transport component that consists of the towing part, the trailer or the container, and is registering the driver. And then this is known at the gate, so once the truck approaches the gates, all automatically recognized. The driver has to do a biometric check, and then it's automatically the loading papers in his destination, where he has to go, and the plant is given to him, so within like half a minute he's through the gate. And then obviously the truck is recognized at the wait stations, the load and the unload stations. And then it's going down the process again, and the way out is pretty similar. I've brought a little video that shows how that process works at the Kenya plant. This is from Leverkusen. I hope it works. Doesn't? Did it work before? This means but we have fallback here. Plan B. Here it is.
The GATE project at Chemion reduces the truck turnaround times in Chem Park to 60 minutes per vehicle. First, the drive is booked in advance over the internet. Trucks predisposed for the order must be equipped with up to 3 RFID tags. 1 tag for each truck and trailer, and possibly for a container. The data in the vehicles is automatically read out in the gate lanes at check-in via RFID tags and transferred to the flow system. Next, drivers identify themselves at the multilingual self-service terminals with their personal flow card and by biometric fingerprint. Printing of accompanying documents is performed automatically. During check-in as well as during check-out, the driver receives the required documents within a few seconds without having to leave the vehicle. The entrance weighing is performed simultaneously. In the next step, the safety and dangerous goods checks are conducted on the spot at the truck with electronic checklists on handhelds, and the results are archived electronically in real time. All truck drives are displayed in a control and planning cockpit in real time by flow, indicating their current process step. Thus, the truck afflux to the loading bays is controlled perfectly, including the waiting time management. Via SMS, drivers can be called up selectively. Now the loading or unloading is done at the factory, where for the chem park customers there are more opportunities for optimization through flow technology. The truck is detected by RFID in the gate lanes at the checkout, and the driver receives the necessary documents at the self-service terminal as well. At the same time, the checkout is being booked in the customer's ERP system. Conclusion: with flow, all processes are monitored and controlled in real time, and that until the end. The flow card also opens the exit gate barriers. The entire process cycle can be passed without stepping out of the vehicle and without waiting.
So this is the process for the plant in Leverkusen, and this is just showing the process at the gate. It's not showing the process within the plant, but recognition at the loading and unload station is pretty similar. What have we seen? The driver is staying in the truck. There's no need to get out, lining up at the counter and getting all his paper stuff. There's a time reduction of 1 hour per turnaround at a target. We've already reported by BASF that they guaranteed 30 minutes. So, but the system is just actually starting. There are no bottlenecks based on lining up the drivers at the gates anymore. On the different steps in the process, documentation is created automatically and not has to be like scanned or whatsoever. And the use for the forwarders simply is they just use one device for their different businesses. As you have seen in the video, there's real visibility of the process where your plants, the trucks in the plant, and all this data also allows for better optimization. And we've discussed these things before. You know, trucks are stuck somewhere, or vice versa. And this was a discussion we had with forwarders. One comment was, yes, we know we have all the problems on the road, but we know those problems. But more problems we have in entrance to the plants and within plants. So that system obviously will provide data for optimization and real-time control and visibility to get that process more effective. And that was it. You are free for lunch now. Thank you.